I wanted to mention all these projects because they're kind of based on the same the same thing, which is open frameworks. All these three projects are open frameworks projects, which I mentioned before. It's kind of the C++ toolkit for doing something like processing does. And so this kind of leads me into the domain of open source. If I had to give a title for this talk, it would be something like what open source means to me, or something like that. And yeah, so I mentioned processing before. This was kind of my first introduction to open source code. Whenever you generate a processing applet that you want to post online, it automatically includes a link to the source code for you, and it says built with processing. The built with processing is really nice because it allows you to index things on Google. You can just type built for processing and you can find a bunch of other applets that people have made. And the source code is nice because it means that if you want to know how someone did something, then you can learn from it. Or if you want to modify it and use it for your own purposes, you can also do that. Yeah, and so when you click on the source code, you get something like this. This was the sketch I mentioned, like the first one I made in processing, where I was porting some gravity simulation stuff. I found it on archive.org last night, unfortunately. Yeah, and so right after I started writing processing, I was still kind of using it at the same time as ActionScript, and I didn't really know what was going on with open source. I had a feeling of like, oh, my source code is automatically posted. That's kind of neat. I saw a bunch of people writing tutorials for different things. I thought that was kind of neat. So I gave a shot at writing my own tutorial. This is something else I found on archive.org, unfortunately, last night. This is, yeah, I call SOHCAHTOA, this trigonometric mnemonic device, I call it a pneumatic device. And this is like when I'm a freshman in college or something, which is really bad. Yeah, but I'm kind of explaining how to do angle detection in ActionScript. You know, you want to use the arctan2 function, and this is how it works. And this was like one of the first things that I thought was like one of my major contributions. I was like, yeah, I'm sharing like this knowledge that took me a while to understand really intuitively. I'm trying to present it in a way that my math textbook didn't present it to me. Like I said, I still didn't really understand what was going on, but I had this feeling of like kind of openness and sharing. There was something important there. This project, Theramug, this is the first thing that I think really helped me understand how social media, social content kind of fits into open source. Really simple project. So I have a cup of tea there, and I have a cable that I plugged into the cup of tea, and the cable's just plugged into the mic input on my computer. I'm using this really simple effect. I don't know if you guys had heard this before, but like if I unplug this, maybe, oh no, there's no ground loop. You can't hear it. You ever get that buzz where it's like a whoa? Yeah. So, sorry. So if you have your cable unplugged and you get that buzz, it turns out that that buzz is directly correspondent to your distance and kind of your how much. It's basically a function of the capacitance that you have with the cable, which is related to things like distance and how much you're surrounding it and stuff like that. So what I did is when I realized that, I made a bigger object. I basically made an antenna out of the exposed cable, which is, well, the antenna is the cup of tea. And then I processed that using this really simple patch. It's like a max patch that looks something like this. It's not really clear right now, but it's a pretty short patch. And when this video, Theramug, got like 60,000 views, I was really surprised, and I published that patch when people started asking me like, how did you do this? And I kept getting positive feedback from people saying like, oh, I just use this technique in this performance, or I just use this technique to make my own instrument, or you know, I didn't realize that you could cut a wire like that and plug it into a cup of tea, or, you know, all these different comments. And I thought, wow, okay, now I think I I understand that there's something about, well, this video is on Vimeo. All of the previous stuff I'd done was basically on this little website that I made that was like one page on a server at my school. And I was thinking, well, maybe the difference is that this is like on a social server. This is on a place where people are already gathering and watching videos together, and you know, they have their accounts and they're commenting, and there's this protocol about what Vimeo is. It's like the same thing with MySpace. Do you guys remember when it was nice to go to MySpace and be like, oh yeah, I'm gonna get like 3 songs from this band. I can just click on the songs, and you know what to expect. It's kind of nice. Like Vimeo, Flickr, they all work the same way. And so I started moving everything over from my website onto these kind of social places. Like Flickr, I was posting the photos there about how things worked. On Vimeo, I was starting to like make videos of different experiments or just like weird things I saw in daily life that I thought someone should do something with. I started to share bookmarks on Delicious instead of keeping them in my browser. I was making a lot of music, so I put that on SoundCloud. Just thoughts that I had, I was putting them on Blogger. I started when Open Processing came around, which is a place to share your processing sketches online, kind of like Flickr. Well, Open Processing is to processing sketches what Flickr is to photos. When Open Processing came around, I took all the processing outlets off my website and put them on Open Processing instead. And Golan, well, this summer convinced me to get a Twitter account, so yeah. And yeah, and other things like Instructables, really nice for sharing kind of the tutorial-like things. Like I showed that tutorial earlier. It was on some ActionScript website somewhere. There's a little bit of a community. You can comment. You didn't really, the protocol wasn't well established. It was kind of constantly under revision. So now I've got like a bunch of these Instructables, and I was thinking about making a data visualization, because like this top part here, this is like the part that I make, right? So these are like 1, 2, 3, 4. These are 5 Instructables I had on Instructables I just took screenshots of. So this top part here is like the content that I type initially, and everything down here, below this line, is comments, and it's like discussions with other people that are interested in this stuff and trying to get it to work. And I realized that the data visualization would be like a pie chart, you know, like the top half is like the make and the bottom half is the share. So I think maybe that's something like what open source is for me. It's this much making and then this much sharing. Yeah, and so the comments kind of look like this. It's people posting images and me responding to them and saying, hey, it looks great, maybe you could try this. Or people saying, why isn't this working? And I say, well, maybe it's because of this. And so now if you go to my website, I don't have any projects on my website anymore. I mean, I have projects, but they don't go to my website. This is actually, like, has anyone studied like web design as a, I don't know, like if you want to be a web designer, you should like study web design, and there's things that you want to do, like not redirect people off your website. Has anybody heard of that before? Okay, so I'm doing like exactly the opposite. Instead of kind of keeping people on my website, I feel like the way that I, as an artist, am meaningful is actually through the way that my work is contextualized, whether it's on Flickr or Vimeo, or if it's in a newspaper article or a blog post. And that's what my website's become. Nothing is, well, there's like 2 things that I can't really post anywhere else. But almost nothing is on my website anymore. So you get a project, and then you get these little links beneath that are basically saying, you know, here's where you can find a connection to that work. So I've been trying to take this really to heart and understand like open source, not just in the way that I write code, but also as it extends into like a community-based experience of artwork and code and all these other things. So yeah, continuing along this open source line, this was, yeah, I guess that was kind of a more theoretical rant, but I'm going to mention just some more projects now since I wanted to show some things that might inspire you guys. So let's see, I think it was like 2 summers ago, I did a bunch of these open source interaction projects, kind of along the lines of the Theramug, where it was like a simple thing that you could probably build yourself, but did something kind of unusual. So I continued like the Theramug capacitive interface stuff to make this 3D interface where there's like 3 things of aluminum foil on a pizza box. And there's like 6 resistors over here plugged into an Arduino. So there's absolutely no active components except for the microcontroller. Who's worked with an Arduino before? Okay, all right, great. Yeah, and so this is something where basically you do about half an hour worth of soldering and cutting in aluminum foil, and then you upload the code, and then you have this thing where you can play 3D tic-tac-toe, which after I posted this, someone told me, apparently, whoever plays, when you play 3D tic-tac-toe, whoever goes first always wins. Like, it's not like normal tic-tac-toe. Apparently it's like you always win if you go first. There's no way to tie. So I guess that was the wrong game to demo, but anyway, this was this was kind of one of these first DIY interfaces I did 2 summers ago. The next one is called IE Beats. So that's my laptop screen. You can kind of see it. You're looking at it from above, and it's kind of laid down flat like this on a table. And that little blue light is from a webcam that I have on some cardboard, again, sitting above the screen. And on my screen, does anybody know what these are? Can anybody guess? M&M's. No, close, really close. Skittles.
Mentos.
Mentos, that would have been better. Because they're bigger, right? It would have been easier to track.
Microdots.
Oh, what about like the dipping dots?
Ooh.
That would have gotten really messy though. Yeah. Anyway, so I saw this interface called the ball bearing sequencer, and it looked like it probably took about a year to make and lots of electronics expertise, and if you wanted to buy one, it probably would have cost $500. It looked really nice, but it's not the kind of thing that you could make yourself if you wanted to just experiment with step sequencing. So I took a weekend and threw this together instead, using Skittles, because I figured, you already have this active interface, which is your screen. You just have to separate that from the things that are on top of it, which you can do. Use some basic computer vision techniques, and you can do that. And so then I did this all in processing, and I fed the results to Reason, which is this kind of audio composition and synthesis program. And it allowed me to make something that worked like the ball bearing sequencer, but people could make it home. Kind of democratizing the technology. I continued this sort of line of research. Does this look familiar? This was before I went to New Zealand. People were waving their cell phones around the same way. This is where we got the idea for that one. So this is the same principle. It's a step sequencer. And you can kind of see people's images on there. Or you can see the image from the camera on the screen with an overlay on front of it that shows what the computer is thinking. So I'm guiding people through. This is an open mic at my school, and I just set this up on the projection screen, and I was like, okay, let's do an improv set. And I started by saying, all right, everyone just do kick drums, now I'll do snares, and now let's get a bass on the 1, and then a snare on the 2, 3, something like that. And then people just started kind of going crazy and improvising. Yeah, so you can get these really weird kinds of interaction with super basic input devices like cameras. I mean, Golan probably wouldn't say that they're super basic. I think it's just that
there's some very basic things you can do, and there's some very simple code that's available online to.
Yeah. Well, I was thinking more like when you got started doing camera-based interaction, it wasn't super basic.
No, it wasn't.
It was a little harder.
It wasn't so hard 15 years ago, but yeah.
Right.
It wasn't so easy.
Yeah. So I'm planning on kind of coming back to that at some point, kind of hardware and more open source interaction. But right now what I've been doing a lot of is contributing to open source software projects, primarily open frameworks actually, making what we call add-ons for open frameworks, which are something like in processing, I think they're libraries. They're like external collections of code that you can use to do things that you can't normally do with the toolkit. So this is my Google Code website. This is like where I post a bunch of different source code that people can use, and so you can go here and see, here's some source code for doing, let's say, here's some source code for doing like a particle simulation. I'm going to go grab that and make something out of it. So here's like what I was doing with it. Kind of basic, lots of particles interacting with each other and moving the mouse around. Making strange patterns, explosions. And then after I posted it, someone else sent me a link and they said, well, here's what I did with it. So they took it and they made it into this big interactive piece, and you could, he had a camera and was watching people, and you could kind of wave the particles around instead of just using a mouse to click on something. And he was sonifying it, and every particle made a sound, and it turned into this really dense interactive piece that he had at some opening in Buffalo. And so this I see as kind of the natural, like, give and take of like open source software. There's this big process of kind of sharing your stuff, and then other people using it, and then you end up using their stuff and using it for your own ideas. Here another example. I posted an FFT add-on recently, and then there was this program called Graffiti Analysis, or a project called Graffiti Analysis, and I was really surprised to see that they were using it for doing audio analysis for their graffiti software. So the biggest project the biggest open source project I've undertaken so far has been democratizing real-time 3D scanning. So on the right here, you can see this is kind of the first results I was getting from my 3D scanner setup. The basic idea is that you have a projector and a camera, and this is a technique that's been around for probably 15 years, but it hasn't really been available to artists and people who just want to mess around with it. It's primarily been like in academia and people who are like writing research papers. So did anyone see like the House of Cards video by Radiohead, or for Radiohead? Okay, there was this funny music video for this British band Radiohead, and they had their faces there in 3D, and the faces were like moving in real time. I mean, they were like, let's say they were talking or something or singing, and you could see the face in 3D singing and talking. And I was really amazed by this, and went out to kind of find out more. And when I found out that they were just using a projector and a camera, I thought, well, that's really silly. Why isn't everyone doing this? We all have projectors, and we all have like cameras, even on our laptops now. So I started writing some code that used the projector and the camera in the right way, according to these academic papers. And since I have kind of a computer science background, it was kind of the ideal thing, because it was a bunch of computer science papers, but I knew that it wasn't going to be available to myself or other artists unless someone with a computer science background kind of stepped in and did something about it. So I started off getting scans back like this. This is my girlfriend, not very flattering 3D scan of her, but you can see this is her neck down here, this is her chin, and the rest is her face and her hair. And it wasn't very encouraging at first, but it was really exciting to see just something in 3D, anything in 3D. A few months later, I got like the scan on the left of a guy who actually does 3D research at my school. And started thinking about it more, thinking like what I could change about the system, what I could optimize. Part of the problem was like, how do I do this in real time, like they did with the Radiohead thing? Because I initially started with a system where you could just take like a single scan, a single 3D scan, and there's already a ton of other systems for doing single 3D scans with like lasers. So I wanted to do something that specifically hadn't been done before, that was basically offering people a new tool to make something that, basically helped create a new media that people could use in a democratized way. This is Rich Pell. He's a professor here. So they may have Rich Pell. Yeah, okay. So when I was here at Studio over the summer, I made some more improvements to it and took a scan of Rich. So this is kind of what the results look like. This is my girlfriend again. Really, really glitchy, but it's super exciting to just see motion in 3D. That's me. And this is actually 6 months old with a $30 camera, and I've done this more recently with a nicer camera and gotten really nice results.
What'd you do today?
I got turned into hundreds and thousands of little points.
Are you gonna be okay?
So this is kind of a takeoff on the usual. I don't know if you guys have ever seen like academic computer vision research videos, but they're always like super, like poorly acted and like super. So I wanted to make something kind of like that to show that I had this new thing that people could play with. So it's kind of an inside joke, but I think a lot of people saw that and were like, "Oh, great! I can do something new," and they didn't even get the joke. But yeah, so I've been using it more recently for just like experimenting with different kinds of rendering of 3D point clouds. Yeah, this is really dark, so it's hard to see, but I was using like depth of field effects to try and render it in a more sort of camera-like way. And then recently I went to Linz in Austria to an installation with Theo Watson, Zach Lieberman, and Daito Manabe that use the same technology called the Janus Machine. This is what the 3D scanning looks like. That's on purpose, it has to be that way. Really basic principle, and it's like not conceptually deep at all. It's basically let's make a bunch of really pretty particles from a 3D scan. So we got together and we said let's have a pedestal over here where you come sit down, you press a button, and then it does a 3D scan for like 3 seconds, and then you go and you're next to another pedestal that has a 3D mouse on it. It's this really cheap. It's like a $99 3D mouse where you can have 6 degrees of freedom, like up, down, left, right, forward, backwards, and then rolling in each of those directions too. And then we use that to kind of let people explore the scan and look around. And then we just did like crazy transitions from one person to the other. This documentation isn't online yet, but because we're still kind of putting it together. So yeah, last section, noise and glitch. So I don't know if you can really tell, there's kind of this undercurrent to a lot of what I do. It's a maybe it's my aesthetic. I don't know what you call it, but I'm really interested in noisy things, like things that well, I don't know. You guys can probably identify noise. It's like porn, right? You know when you see it. Maybe you can't define it.